What killed the rotary engine? The rotary engine was once a groundbreaking invention in the automobile industry, especially made popular by Mazda in vehicles like the RX-7 and RX-8. It is renowned for its distinctive design and high-revving performance. But despite its initial popularity, the rotary engine eventually encountered serious problems that caused its production to fall out of favor. In this video, we will highlight 7 key reasons for its decline. Number 7. Poor fuel efficiency. The unique architecture of the rotary engine, which makes efficient combustion difficult, is mostly to blame for its low fuel economy. Fuel and air are combined, compressed, and ignited in a chamber that permits controlled combustion in a conventional piston engine. In order to extract energy, fuel is burned at a particular instant as the piston goes up and down inside the cylinder. On the other hand, a triangular rotor inside an oval-shaped casing rotates constantly in a rotary engine. The fuel combustion process is not as strictly regulated as it is in piston engines because of its rotating motion. Greater heat losses and less effective combustion result from the combustion chamber's shape and the rotor's movement, which increase the surface area exposed to the burning fuel. Additionally, because of the engine's design, many combustion cycles occur during each turn, increasing the amount of fuel required to produce power. The inefficiency of the rotary engine became increasingly noticeable over time, particularly as global fuel prices increased and fuel economy regulations tightened, in contrast to piston engines, which are better suited for fuel use. The rotary engine's heavy fuel consumption became an unsustainable disadvantage in an era of increased environmental consciousness and rising fuel prices. Number 6. Emissions issues. The rotary engine's inefficient sealing and flawed combustion process were the main causes of its emissions issues. The intake and exhaust valves of a piston engine are regulated to open and close at specific times, guaranteeing optimal combustion and effective expulsion of exhaust gases. Apex seals, on the other hand, are used by the rotary engine to keep the rotor and housing sealed. Over time, these seals may deteriorate, leaving tiny openings that let air and unburned fuel escape during combustion. Increased emissions of dangerous pollutants such as unburned hydrocarbons HC, carbon monoxide, CO, and nitrogen oxides NOx result from this incomplete combustion. Particularly worrisome are the enormous amounts of unburned hydrocarbons which contribute to smog and poor air quality, particularly in urban areas. Manufacturers like Mazda tried to employ cutting-edge exhaust treatment technologies like catalytic converters and secondary air injection systems to comply with environmental laws in the 1980s and beyond. However, as emission regulations tightened, these systems were unable to adequately control the significant emissions generated by rotary engines. On the other hand, piston engines were better suited to comply with environmental requirements due to their cleaner exhaust systems and increased fuel efficiency. The rotary engine eventually declined as a result of finding it more and more difficult to meet government regulations. Number 5. Durability and reliability concerns. One of the rotary engine's biggest disadvantages was its long-term dependability and durability. The engine's apex seals, which are essential for maintaining compression and producing power, can deteriorate over time, particularly when the engine is operated at high revs or under heavy load. Over time, these seals deteriorate because they are always under strain to keep the rotor and housing sealed. When the seals deteriorate, the engine loses compression, which significantly impairs performance and frequently results in total engine failure. With high-performance vehicles like the Mazda RX-7 and RX-8, where drivers frequently push the engine to its limits, this issue was very common. Another concern was that the rotary engine's design led to uneven wear across the components, as the rotor's rotation created areas of higher stress. Because the oil was blended with the fuel for lubrication, the engine also consumed more oil at a faster pace. Despite being a component of the design, this raised the overall cost of upkeep. The cost of maintenance was higher than for conventional engines, since owners frequently had to replace the apex seals rather early in the engine's life. The rotary engine's reputation for requiring frequent maintenance and repairs further contributed to its fall in widespread use as consumers' concerns about reliability grew, particularly for those looking for a car for everyday use. Number 4. Complicated cooling needs. Another problem with the rotary engine was cooling. The rotary engine features a single, continuously rotating rotor in a housing, in contrast to traditional piston engines, which have several cylinders each with its own cooling channels and a sizable surface area exposed to coolant. This architecture makes controlling the heat produced by combustion extremely difficult. As the rotor rotates inside the housing, it doesn't have the same degree of direct exposure to the cooling system as piston engines have. Because of the engine's small surface area and lack of a conventional cylinder block, coolant has a harder time effectively absorbing and dispersing heat. As a result, the engine is more likely to overheat, particularly in hotter climates or when used for extended periods of time. The engine may experience thermal expansion problems if it is not sufficiently cooled, which might cause the housing to deform or even the apex seals to break. Furthermore, the cooling system had to work harder than it would have in a conventional engine, due to the engine's significant heat generation in a small space, thus necessitating the usage of additional systems like oil coolers. The basic problem of cooling the rotary engine persisted as a major disadvantage despite engineers' efforts to create more efficient cooling methods. The cooling issues with rotary engines became a glaring disadvantage in the market as traditional piston engines and their cooling systems grew considerably more efficient as automobile technology advanced. Number 3. Limited power output. While the rotary engine has the ability to rev very high, often well beyond the red line of most piston engines, it suffers from a significant disadvantage when it comes to torque delivery, particularly at low engine speeds. Torque is a crucial factor in everyday driving because it's what allows a vehicle to accelerate smoothly, especially from a standstill or when driving at low speeds. Traditional piston engines generate torque in a more linear manner, meaning they provide a consistent and strong pull across a broad range of engine speeds. The rotary engine, however, lacks the torque at lower RPMs that many drivers expect for a smooth driving experience. For the average commuter or everyday driver, having a strong low-end torque is more important than having a high RPM because it makes driving easier and more convenient in urban areas. The rotary engine's high-revving nature made it ideal for performance vehicles, but it was less practical in mass-market vehicles, where broad power delivery and smooth acceleration are highly valued. A rotary engine's ability to produce peak power at high RPMs limits its usability for general driving. Number 2. High production costs. The precision needed to construct the rotor, housing, and apex seals was the main reason the rotary engine was costly to make. The materials used for the apex seals must be extremely durable to endure the high heat and friction inside the engine, and the rotor itself must be manufactured with precise tolerances. In contrast to traditional piston engines, which are simpler to manufacture in large quantities and have a cheaper cost per unit, the manufacturing process for these components necessitates a high degree of accuracy, which raises production costs. Furthermore, the rotary engine's assembly is more complicated because of its special design, which necessitates more elaborate procedures to guarantee that the rotor, seals, and housing fit correctly. Apex seals and other replacement parts are more expensive when it comes to engine maintenance. Given the growing competition from more affordable piston engines that could be built in much larger quantities at lower cost per unit, the high cost of production was a significant worry for automakers. The rotary engine's high production and maintenance costs made it less appealing to manufacturers that were attempting to maintain competitive prices as the automobile market shifted its attention to affordability and mass production. Number 1. Advances in conventional engines. Traditional internal combustion engines ICE had major improvements over time, becoming more dependable, powerful, and efficient. Turbocharging was one of the major advancements that made it possible for smaller engines to provide more power without compromising fuel efficiency. As a result, piston engines were far more fuel efficient and performed better. Additionally, traditional engines were able to operate more effectively, cleanly, and with improved power delivery because to innovations like variable valve timing (VVT), direct fuel injection, and sophisticated engine management systems. These advancements made conventional engines more competitive with rotary engines in terms of overall performance and adherence to strict environmental standards by greatly reducing their emissions and fuel consumption. Furthermore, the rise of hybrid and electric vehicles presented a new threat to the rotary engine, offering a much cleaner and more efficient alternative to traditional ICE vehicles. These factors collectively led to the decline of the rotary engine in mass-market production, despite its unique appeal and a devoted fan base. Thanks for watching our video, and don't forget to subscribe.